Today I'm going to cover 11.5, the R Formulae. Okay, the textbook itself, please do a quick read through on page 291, I think, with regards to the derivation of the formula itself. So now what I'm going to do here is this. I'm just going to go through how we actually apply the R formula. Okay, the first example itself, example 18, we'll talk about how we can apply how we can use the formula actually. So not to worry, this formula is actually given, okay, but what you need to do is you need to memorize how to actually derive the R value and how you get the alpha value itself. Okay, now let's just delve straight into example 18. So for example 18, we want to express this as a single trigonometric function. How I know that this is an R formula question is because there's one term that is sine and one term that is cosine, and I need to combine them into a single trigonometric function. So without much further ado, let me begin with part A itself. So first I will say let 12 sine theta plus 5 cosine theta is equals to R sine theta plus alpha. Okay, here's the trick. If sine's in front, okay, what you will get, right, is R sine theta. If cosine is in front, what you get is R cosine theta. Okay, so now what I'm going to do here is this. How I get my R formula is this. I'll take 12 square plus 5 square. Okay, then I will square root this. So where I get 12 and 5, you can see clearly these are the numbers before sine theta and cosine theta. Then what I'll get is, over here, I'll get the value of 13. Okay, now how do I get the alpha value? It's always the second value over the first value. So, and always you just take the absolute value. So even if this sign here is negative, it's perfectly fine. Okay, so now you just use, even if it's negative 5, you just take positive 5. So tangent alpha is equals to 5 over 12. What I find is that my alpha value is equals to 22.6 degrees. Hence, 12 sine theta plus 5 cosine theta is equals to 13, okay, sine theta plus 22.6 degrees. That's it for part A itself. Now, if you can just let me quickly go through part B itself. So for part B, it is this, okay, negative 2 cosine theta minus 3 sine theta. Okay, be very careful, all right. For this R formulae, the first number or the first function for sine and cosine has to be positive. If you notice down here, this is actually negative 2. It doesn't work. Even if I were to shift the terms around here, I put negative 3 sine theta minus 2 cosine theta, the R formula still doesn't work because this is a negative 3. But not to worry, what we can do is apply factorization to help us. So what I can do here is this. First, I factorize negative 1. So if I factorize negative 1, what I'm left with is 2 cosine theta plus 3 sine theta. Then what I can do here is this. I will say let 2 cosine theta plus 3 sine theta equals to R. Okay, cosine is in front, so it will be R cosine theta minus alpha. Okay, why minus alpha? You just look at the formula sheet. Cosine will always be the opposite. So here is cosine plus sine. For cosine, this plus will become a minus here. Just follow the formula sheet, you'll be fine. Again, the R is 2 square plus 3 square. I square root this. My R value gives me square root of 13. Then alpha. Tangent alpha, second value, B over A is 3 over 2. So alpha itself will give me 0.983 radians. This question they actually asked you in radians. Hence, if I go back to my first line here, what I get is negative 2 cosine theta minus 3 sine theta. Equals to negative. Okay, so now the equivalence of this is this, and we have calculated the R value and alpha value. Hence, this becomes negative square root of 13 cosine theta minus 0.983 radians. And that's it for 18. Now, please pause the video and try it 18. So pause the video, try 18, and I'll give you the answers shortly. In 3, 2, 1. Let's go. Okay, for part A itself, what happens here is this. So same thing as we have done in the earlier example, we find the R value. So you take 2 square plus square root 3 square root, you get root of 7. To find my alpha value, you take square root 3 over 2. What you obtain is 40.9 degrees. Then you just put it into what we have formed here, this expression. So it's R sine theta plus 40.9 degrees. Similarly, for part 2 itself, no need to do any factorization. 3 here is positive. Notice that cosine is in front, so you will form an R cosine, okay? But for cosine is special, negative will become positive over here. Don't worry, or in the formula sheet, just be careful when you apply from the formula sheet itself. So what happens here is the R value is 3 square plus 4 square. Notice I ignore the negative symbol, just take the absolute value of 3 square and 4 square. You square it, your R value is 5. Tangent alpha is 4 over 3. Once again, notice that there is no negative symbol, even though here is negative 4. Just take the absolute value, 4 over 3. You inverse tangent, you get 0.927 radians. So this function, if you write it out in as a cosine function, is 5 cosine theta plus 0.927. And this is in radian mode. Okay, example 19. Express 3 sine theta plus 4 cosine theta, okay, in R sine theta form, and then find the maximum and minimum values. So now, same thing in part 1. What I'm going to do here is this. I will let R, I will let 3 sine theta plus 4 cosine theta is equals to R sine theta plus alpha. So this one again from the formula sheet. So I think by now we're getting quite used to this. The R value, okay, simply the R value gives me a 5. Then to get my alpha value, tangent alpha is second over first, 4 over 3. So my alpha value is 53.1 degrees. Hence, okay, what I can say is that 3 sine theta plus 4 cosine theta is equals to 5 sine theta plus 53.1 degrees. Okay, now I go on to part 2 itself. Okay, so from part 1 we had that already. So part 1, what we have is 5 sine theta plus 53.1 degrees. Now for part 2, find the maximum and minimum values. Okay, this is actually talking about the amplitude itself. So the amplitude, right, see, as we have learned earlier, the sine function, max value is 1, mean value is -1. So in this case, the 5, okay, is the amplitude itself. So the max value occurs when you take 5 times +1. That's the maximum value, and the maximum value is equals to 5. Similarly, you take 5, and the lowest value that sine theta can go is -1. So 5 times -1 will give me -5. So now let me work out the max value. So the maximum value is equals to 5 times 1 equals to 5. When sine theta plus 53.1 degrees is equals to 1. Remember, sine and cosine function, max value is 1, mean value is -1. So if I inverse sine of 1, what I get is 90 degrees. So my theta value is 90 minus 53.1. Theta value gives you 36.9 degrees. So similarly, my minimum value is equals to 5 times negative 1. So this is when my sine theta plus 53.1 degrees equals to negative 1. So where does, for the sine graph, where does negative 1 actually occur? It occurs when at 270 degrees. Okay, what I'm talking about is this. If you were to sketch a sine graph, 0, 90, 180, 270, 360. Over here is 270 degrees, you get negative 1. So what I'll get here is theta is equals to 270 minus 53.1. I get 216.9 degrees. So I say minimum value when theta equals to 216.9 degrees. Okay, do attempt try 19. Find the exact maximum and minimum values and the corresponding values of theta when theta is between 0 and 360. The difference now is there is a negative 2 here. So my hint to you before I try 19 is to express 6 cosine theta minus 4 sine theta in the form of r cosine theta plus alpha. Once you've expressed that, you can actually work right with the maximum and minimum values, okay, and you'll see how it interacts with negative 2. Then you can get the exact minimum and maximum values. So now, as I said earlier, I present to you the answer now. What I'm going to do is I actually express 6 cosine theta minus 4 sine theta in the form of r cosine theta plus alpha. So what I get, I will just skip all the explanation for that part. What I get is 2 square root 13. Okay, this is not a good color to use. I get 2 square root 13 cosine theta plus 33.7 degrees. Okay, now see slowly. Okay, so now my whole function from 6 cosine theta minus 4 sine theta minus 2, this part here becomes 2 square root 13 cosine theta plus 33.7 degrees and minus 2. So see this value here, the maximum value is 2 square root 13 times 1, okay, and the minimum value is 2 square root 13 times negative 1. Alright, this occurs when cosine theta plus 33.7 degrees is equals to positive 1. Again, because the maximum value of a cosine function is 1, minimum value is negative 1. Similarly, this occurs when cosine theta plus 33.7 degrees equals to negative 1. So for this part here, I will say that the maximum value occurs at 2 square root 13 minus 2 when cosine theta plus 33.7 degrees equals to 1. I solve, okay, so cosine function equals to 1 at 0 and 360. So if you remember the cosine graph, okay, at 0 degrees is 1, 360 degrees, okay, is also equals to 1 itself. So it's 0 or 360. So eventually, if you solve, you get 326.3 degrees. So maximum value is this at 326.3. Minimum value is when cosine theta plus 33.7 degrees equals to negative 1. Hence, you get 2 root 13 times negative 1 minus 2. So you get negative 2 root 13 minus 2, which is shown here. Then, where is the cosine function negative 1? If you draw a quick sketch, okay, of the cosine graph, this occurs at 180 degrees, down here like this. So the corresponding theta value is 146.3 degrees. Okay, example 20, solve the equation. So, okay, normally, I think what we have learned previously, if you see a cosine, you see a sine, then we say, hey, why don't we just divide everything by cosine theta to form the tangent function? That idea here will fail because of the extra number here. Let me just give you a quick show of why it will fail. If I divide by cosine theta, I divide by cosine theta, I divide by cosine theta, what I'm getting is square root 2. Okay, that's good. Sine over cosine is tangent theta. Then over the other side, right, I will get secant theta. Oh no, not good. Okay, why no good? There's a tangent theta, there's also a secant theta. So in cases like this, when dividing by cosine theta actually does not help, what we can do here is this. Okay, why don't I apply the R formula itself to this and this? So I can say this, let square root 2 cosine theta plus sine theta equals to R cosine theta minus alpha. So your R value is root 2 square plus 1 square square root. What I get is square root of 3. Then tangent alpha is 1 over root 2. My alpha value will give me 0.61548 radians, correct to 5 SF. So therefore, what I can say is this function, okay, will now become square root of 3 cosine theta minus 0.61548, okay, is equals to 1. The 1 is from here. Notice there's only a cosine here and a number over the other side. This is quite easily solvable already. So what I will obtain here is cosine theta minus 0.61548 is 1 over square root 3. I divided by root 3 on both sides. Then what I can do here is this. If I inverse cosine 1 over root 3, I know that since cosine function is positive, what I'll get is first quadrant and the last quadrant itself. So what I can do here is this. I will find, okay, that my reference angle itself will be 0.95532. So what I will get here is this. My reference angle okay, is equals to 0.95532. How I get that is I take inverse cosine of 1 over root 3. So therefore, what I can get is theta minus 0.61548 is equals to 0.95532. Okay, if I take this, okay, then what I can also get is the angle is I can actually minus 2 pi, okay, or I can get, okay, see what we can get down here is in the first quadrant and last quadrant. So this angle here is 0.95532. I can also get this angle here. Okay, this angle here will be this one, 2 pi minus 0.95532. Then if I can minus another 2 pi again, it means I go backwards. Remember, adding 360 and minusing 360, you get back the same angle. So the other angle I can get is negative 0.95532. So my theta value is simply negative 0.340 and 1.57 radians. Okay, example 20 still. Try 20. I will just give you all a while. Pause the video. Please give it a shot. I think what you can do at the very least is to express this in the form of R cosine theta plus alpha. Then you can work it out from there. Okay, if you have done this, what happens is you have expressed it in the form of the cosine function. So from this step here, you get 2 cosine theta plus 60 degrees equals to 2. Dividing both sides by 2, you get this. Theta plus 60 equals to 1. So if you inverse cosine, okay, 1. Where is a cosine function equals to 1? Is at 0 degrees and 360 degrees. Then you solve, you get negative 60 and 300. And your try 20 is actually done. Okay. example 21 actually talks about how we can actually apply this formula, okay, in what I call the R formula to actually solve certain questions itself. So in example 21, what you do here is this: explain why h equals to 5 cosine theta plus 6 sine theta. So what is h? Okay, so h, right, is this length over here. So basically h is equals to FA plus AE itself. So if I were to consider triangle FAB, okay, like this, okay, AFAB, and the other triangle I can consider is triangle AED. Okay, slowly if this angle is 90, this is theta, this necessarily means that this angle here is 90 degrees minus theta. Okay, then okay, this angle over here is 90 degrees because it belongs to a rectangle. So it means that this angle over here, angle FAB, is equals to 180 minus 90 minus 90 minus theta. So what I get is, if you simplify this, you get theta itself. So angle FAB itself will be theta. Okay, so I got two triangles now. This guy here is theta, and this guy here is also theta from the two triangles. So what I know is that, let me fill in some values. This value here is 5, and this value here is 16. So what I can say is that if I want the length of FA, so I'll say that cosine of theta is AF, adjacent, over hypotenuse. So AF is 5 cosine theta. Similarly, I can also say I want to find the length of AE. So for AE, I'll apply sine ratio, opposite over hypotenuse. So what I get is sine theta is AE over 16. AE equals to 16 of sine theta. So I can write it down, okay, in part 1. My working may differ from the book by a bit. So cosine theta is equals to AF over 5. AF equals to 5 of cosine theta. Then I will say that sine theta is equals to AE over 16. So AE is equals to 16 sine theta. So I say that H is equals to AF plus AE is equals to 5 cosine theta plus 16 sine theta. So I have shown. Okay, for part 2, I will just continue doing it on this page itself. So part 2, what happens here is this: they want me to combine, okay, 16 sine theta plus in the form of r sine theta. Okay, here is where it gets a bit tricky. If I started with 5 cosine theta plus 16 sine theta, what necessitates here is I get r cosine theta minus alpha. But hey, wait, the question actually wants r sine theta plus alpha. So what I can do here is this: I just do a bit of adjustment. I just take 16 sine theta, I move, okay, the plus sign, then the 5 cosine theta I shift. So I put the sine theta out front. So if I put sine theta out front, what happens here is that this becomes r sine theta plus alpha, exactly what the book ordered. So what I get is my r value is 16 square plus 5 square. I square root this. So what I get is my r value is equals to square root of 281. Similarly, tangent alpha is 5 over 16. So my alpha value is equals to 17.354 degrees. So in part 2, the expression that I'm looking for, okay, is h is equals to square root of 281 sine theta plus 17.4 degrees. Notice that I used correct to 1 dp, but later on when you need to do calculations, alpha should be expressed correct to 5 SF so that you can increase your accuracy. So now I'm at part 3. Find the value of theta for which B is 11 cm above AD. So now if B is 11 cm above AD, this actually means that the height is actually 11 cm. So from part 2, what we have is square root 281 sine theta plus 17.4. So I just use back the same thing, square root of 281 sine of theta plus 17.354 degrees. Notice I use the 5 SF value here. Is equals to 11. So what the question is actually asking you is how to solve this. So if I start to solve, I get sine theta plus 17.354 degrees is equals to 11 over square root of 281. I find that my reference angle, okay, is equals to 41.011. So it occurs here, first quadrant, second quadrant. So my alpha is equals to 41.011. How I get that? I inverse sine of 11 over square root of 281. So if I solve this, I'll get theta plus 17.354 degrees is equals to 41.011. Solving, my theta value is 23.7 degrees. You may ask, Mr. Sim, how come you never solve for the second quadrant? Sine is positive, it should occur in first quadrant and second quadrant. But question says it's between 0 and 90 degrees, so I ignored the solution from the second quadrant itself. Okay, I will now try to solve part 4. So for part 4, what happens here is this, the maximum value of h and the corresponding value of theta. So my h value is equals to square root of 281 sine theta plus 17.4 degrees. So basically, the maximum value occurs when square root 281 times 1. Okay, maximum value of sine function is 1, minimum is -1. So I will say that the max value, okay, maximum h is equals to square root of 281, okay, when sine of theta plus 17.4 degrees equals to 1. So if you solve this, you get theta plus 17.4 degrees equals to 90. And the theta value equals to 72.6 degrees. Okay, please attempt try 21. I will not explain everything, okay? Maybe I'll just explain some parts of it, especially like the part 2 and part 3. I'll just show you the solution, okay? But for the part 1, right, maybe I can talk about it shortly. So for part 1 is show that the parameter p units and the area a square units are given by p and a is 12 sine 2 theta. Okay. Okay, first and foremost for this try 21, what I know there is this angle here is 90 degrees. Why? Angles in semicircle. So if I know that XYZ is a right angle triangle, so what I can say that is XZ, okay, is equals to since XZY is equals to is right angle, so xy is actually equals to 2 root 12, okay, and yz itself, right, is 2 root 12 cosine theta. You may be wondering how they get this and this. Okay, this angle is given as theta, so if I want to get xz, see for this portion here, xz, okay, so is opposite over hypotenuse. So what I will take is opposite is sine theta is equals to opposite xz over hypotenuse, which is 2 root 12. So my exact value is 2 root 12 sine of theta, which is what I got down here. Similarly, okay, for yz, what I'm considering is adjacent over hypotenuse. So I will say this cosine of theta is equals to yz over 2 root 12. If I simplify, yz is 2 root 12 cosine theta. So what they want is the perimeter. So perimeter is this length plus this length plus this length, which is shown down here. So if you simplify, you get this. And area is half times base times height. Okay, so your base is xz, your height is yz. You simplify, you should get 12 sine 2 theta over here. Okay, for part 2 and part 3, I won't go through. This is the application of the R formula. So what you get is this value over here. So for the last part is when the perimeter is 14.5, you just plug it into your expression for the perimeter. You can solve and find that the theta is 5.606, so the area is 2.33 itself. And that's it, okay, for this 11.5. I know it's a long video, but